We are now going to talk about part 2 of our lesson 2.6, which is titled Transformations of Functions. And today we're going to talk about the transformation known as a reflection. And yesterday we defined a reflection as a flip. It's as though we're going to take a parent function and we're going to flip it, pick it up and flip it over either the x-axis or the y-axis. And the big part of today's lesson is to help you to identify exactly which axis will the reflection take place. And so I want to give you some key points that will help you when you come time to practicing the homework and identifying exactly where we are reflecting. Is it a reflection over the or in the y-axis or in the x-axis? Okay, so there's my definition of reflection. And your book instructions look like this. Describe the reflection in each function as it relates to the parent graph. And then we're going to sketch the graph. Okay, so here's a problem. Y equals negative x squared. Well, this is a reflection of the parent. You need to be able to identify the parent function. And there are three parent functions that we're dealing with at this point. I'll just go ahead and list them for you. We're dealing with y equals x, which is a line. Y equals the absolute value of x, which is that V shape. And then y equals x squared. So at this point, now we're going to be adding to this list later on as we go through the year, but at this point there are three parent functions that will be the answer to this first question. You're going to pick one of these three. All right, and now let's decide if it's going to be a reflection on, or you might see the word over, really doesn't matter. Is it a reflection on the x-axis or on the y-axis? Well, here's the general principle. If you have a minus sign like this in front of your parent function and you do not see any parentheses or absolute value bars, then this always indicates a reflection over or on the x-axis. Okay, so let's just go ahead and sketch the graph, and I'm going to show the parent function, just the points of the parent function, just so we can have something to relate to. Alright, so here are the points for y equals x squared. And I won't complete the parabola, but those points are used to identify the parent. And so now let's graph the translation or the reflection of the parent. So let's just come up with a table of values. And if we let x be 0, y is 0, so we're at the origin. If we let x be 1, we get a y of negative 1. 1, negative 1. And our line of symmetry, of course, is the y-axis. So there's that opposite point, opposite side. And let's do one more. If I let x be 2, then I get a y of negative 4. Okay? And so this is a perfect illustration of what it means to take a parent function and reflect it on the x-axis. Okay? And that's because we have this minus sign in front of the function, the parent function, and there are no parentheses or any grouping symbols at all. Okay, so that's an example of reflecting over the or on the x-axis. Well, now let's look at a reflection over the y-axis or on the y-axis. Okay, well, this is a parent function y equals x squared again. But notice the difference between our previous function, which did not have parentheses, and this one, which does. And you also notice that my minus sign, the negative sign, is inside the parentheses. All right, well, this situation always creates a reflection on the y-axis. That's also true, and I'll show you on the next slide, that's also true for absolute value. Okay, notice the position of the minus sign inside. That could also be represented in a linear equation like this. Notice the minus sign inside. So that's a key takeaway from today's lesson. Notice the position of your negative sign, and that will tell you whether you have reflection on the x-axis or on the y. So it'll make sense as we come up with the graph. So here's again my parent. Alright, those points represent the parent function. And now let's come up with some points for this function that we're given. So again, 0, 0 is on the graph. If I let x be 1, then negative 1 squared is still 1. And that's also, I got a point corresponding to that because of symmetry. If I let x be 2, negative 2 squared is 4. So really it's the same graph as the parent graph. And I have a reflection. The word reflection just means it creates a mirrored image, and there is reflection on the y-axis. And that's proving again that when the minus sign is inside your parentheses like this will always be true. Okay, so here's some examples again just to wrap this part 2 on reflections, just to wrap this up. Notice the position of the negative sign. Okay, it's in front when there are absolute value bars. It's in front. If there were parentheses here, it would be in front. Okay, the negative sign is not involved inside any absolute value bars or parentheses. Contrast that with reflection in y-axis. The negative sign is inside the parentheses or inside the absolute value bars. So that's how you can tell the difference between reflection in the x-axis, flipping over the x-axis, or a reflection created by the y-axis. Alright, and so that concludes part 2, and the follow-up lesson will conclude our lesson on transformations. We will talk about dilations, and then we will give you the problems, all of the problems that need to be completed for next time.